Zircon is a mineral. It's a natural mineral found all over the world in different regions. It consists of zirconium and SiO2 in a chemical composition, so it's a zirconium silicate mineral. The derivatives are materials that are made from zircon sand, such as zirconium metal, zirconium dioxide, or zirconium chemicals, zirconium oxychloride, for example. So the main use of zircon sand is the use as opacifiers in ceramic tiles and sanitary ware and also tableware. Almost 50% of zircon is used in that application. So zirconium silicate has a very high refractive index. That means it scatters the light very easily, and therefore it can be used as an opacifying agent in ceramic applications, such as in tableware or in sanitary ware and in tiles. It gives a very high brightness level and a very good whiteness level. Other important applications are in refractories and also in foundry, zirconium chemicals. On the other hand, for example, zirconium dioxide, especially in its stabilized phase, has a very high oxide ion conductivity. It means oxide ions can migrate through that crystal structure very easily, and therefore it is used as an oxide ion conductor in solid oxide fuel cells, in the electrolyte, for example, or in oxygen sensors. We have zirconium metal. Zirconium metal has a very low neutron cross section. That means it transmits neutrons very easily without resistance. Therefore, it is used for fuel cladding in nuclear power plants because it helps to sustain the nuclear chain reaction. What else do we have? We have zirconium chemicals. The zirconium chemicals are normally used as materials to make other chemicals. So, for example, zirconium oxychloride can be used as a feedstock to make precipitated zirconium dioxide or other zirconium chemicals, such as zirconium basic carbonate, zirconium orthosulfate, zirconium basic sulfate, that are then used to make more chemicals. The applications for zirconium basic carbonate are, for example, in paint dryers, for zirconium orthosulfate and zirconium basic sulfate in leather tanning agents. Zircon and zirconia make already contributions to variable sustainable applications. We have, for example, the use of ichthyo-stabilized zirconia and thermal barrier coatings. So these are coatings that are applied on turbine blades, for example. And ichthyo-stabilized zirconia has a very low thermal conductivity, and it helps to protect the metal components of the gas turbines, allowing that those gas turbines are run at a higher temperature. And the higher the temperature of a gas turbine, or the higher the temperature difference in a gas turbine, the higher is the yield and the efficiency. That means they consume less fuel. So you save carbon dioxide because you have a lower fuel consumption. We have the use of zirconium metal in nuclear power plants. So zirconium metal is used because of its low neutron absorption cross-section. The neutrons can be transmitted through zirconium metal easily without resistance. We also have a couple of emerging technologies. Zircon itself has a very high solar reflectance. That means it reflects a wide range of the solar light. And if used on roof tiles, it means that the roofs and the houses are colder than they would be if we did not use that zircon pigments. Perhaps I explain a little bit about the urban heat island effect is that we observe in cities that the temperatures are higher than in the countryside. And this is due to the use of a lot of construction materials that absorb the solar light. Now, if you use zircon in roof tiles, you allow a lot of the solar energy to be reflected. This gives you a natural cooling effect and keeps the houses cool. There is another emerging technology I would like to talk about, which is the use of zirconia in solid oxide fuel cells and solid oxide electrolyzer cells. Now, with the recent demand for low carbon dioxide energy sources, there is a huge push now for solid oxide fuel cells. Plus, we are all discussing the hydrogen energy, and you can run a solid oxide fuel cell in reverse mode and also use it to generate hydrogen. So that's an solid oxide electrolyzer cell. And yttrium-stabilized zirconia and Scandia series stabilized zirconia is used in the electrode, but also in the anode of these solid oxide fuel cells and solid oxide electrolyzer cells. This is also very important. Perhaps a more important application is the use of yttrium-stabilized zirconia in oxygen sensors. So you need oxygen sensors in combustion engines, but also in other combustion processes to really optimize your process. Use or the functioning of an oxygen sensor is it measures the oxygen concentration in the combustion gas, and then it feeds back this information to the control unit, and this basically controls the ratio of the fuel and the air, and makes sure that the engine is then run at an optimum level. It means you do not have any unreacted fuel in your emission gas. So there is no carbon monoxide, for example, which is highly toxic, and also no unreacted hydrocarbons. Zircon is used in automotive applications, at least in two different applications. Number one is the use in catalytic converters, where it is used together with cerium oxide. The main function of zirconia here is to store the oxygen, enabling to operate the catalytic converter very efficiently, and it stops the sintering of the catalytic material. Means that the catalytic converter can be run very, very long. The second application is in oxygen sensors. This enables the engine to be run at high efficiency and to consume less fuel. Now, zircon and also zirconia is used in refractory and foundry applications. And the reason for that is, for example, that zirconia has a very high melting point. It is a very refractory material. It is very corrosion and erosion resistant, and therefore it is used in continuous casting of steel, as an example. Zircon, on the other hand, is also used in foundry applications, for example, investment casting. It has a very low wettability with metals, and that creates a very smooth surface of the cast metal piece. Also gives a very low chemical reactivity with a lot of alloys, which also makes it very suitable to be in contact with molten metals. So also zircon and zirconia play an important role in medical applications. For example, yttrium-stabilized zirconia is used in dental implants and also crowns and bridges because it is mechanically very, very strong. It has a very high fracture toughness. It does not break easily, and it offers a very nice aesthetic. Zirconia ceramics are also used in implants, often in combination with aluminum oxide as dispersion ceramics. They are very stable against under hydrothermal conditions, so the biocompatibility with human tissue is very, very good, and that is the reason why yttrium-stabilized zirconia in combination with aluminum oxide is used in these applications. We carried out the life cycle assessment study together with the Centro Ceramico in Bologna in Italy. We found out that if we use zircon opacifier in a super white porcelain tile, we have a lower impact on a variety of different environmental factors. compared with competing solutions, we found 20 to 30% lower impact on most of the environmental factors. There was only one parameter where we found similar impact, which was the ozone depletion potential. Because of the very high refractive index and the strong opacifying effect that Zircon has, this of course has a very strong influence on the environmental benefits.